Hi, Markay here, and welcome to State 3 updates in Unreal Engine 5.5, which just dropped a few hours ago. So I'm doing a speed run. Actually not. I tested everything in preview version and just waited to see if some of the things are fixed. They are not, so I guess live. Yeah, 5.5 is here, and let's get down to business. What has changed? What's new? What's popping? And yeah, the setup I have here is the same setup I use in every video. So I just made a AI character. It's a copy of third person from the third person template, and I removed all controls. So in that AI character, I just added a new stage 3 component, and let's start doing stuff. So, of course, first thing first, we need to make a new stage 3. As you can see, we have some new schema, camera director, and stage 3 anim next, which is actually not something you will see because it's related to a plugin. Because Epic is working on anim next, and it's still not working, still not really usable, but it's good to know they are updating it. Maybe it will replace anim blueprints or something. I really don't think so, but maybe in 10 years, I guess. Except that we have, of course, or rather apart from that, we have stage 3 component and AI component, which is just, component plus AI controller. We're not gonna do a component because kind of useless, but I mean, not useless, but for this example, it's better to go with just a component. Let's call it st tut general, and in that tut general, let's open it up and see what has changed. So immediately you can see there is a new top bar. Well, not new, but it is updated with three more options. We have asset details, which has brand new icons, which are very, very nice to look at. And when we select a state, we have also updated UI in the right side. One very interesting thing that we can immediately see, and it's something that we've been asking for a while, is payloads. And spoiler alert, do payloads work? Yes, they do. And I'm gonna show you how to use them in a moment. Let's just, speed run this overview, and we'll go step by step how everything works. Let's add a new state. Let's just do a very basic example. Of course, we need a standard task that will print something, that will do something, and yeah. So let's do entry. Entry will have a task, and that task we can pick from our new top down. And let's pick state 3 task blueprint base. Let's save it in our tutorial folder. Let's call it stt tut entry and save it. It will immediately open a new editor, and we can do some scripting. So standard procedure, enter state. Let's print something. Let's see if it prints. Let's say hello world. I just typed hello again. It's equivalent of programmer equivalent of deleting a standard cube from Blender, and plug it here into the tasks. Tut entry. Now let's make sure the state 3 is in state 3 component. So to general and to run it. Let's see if it works. Hello world. Hello AI. Welcome to the world. So yeah, this works nicely. And one new thing that you could see immediately, or maybe not that immediately, but if you have a sharp eye, then you will see it, we have a new override function which is called getDescription. And what is this? The getDescription is a cosmetic function. Honestly, it doesn't do much, but when we override it, we can basically change how the state is viewed. So to entry, we could say that it's basically entry state test, haha, right? And when we compile and save it, now we can see that the entry state test, haha, is basically this task, right? So quite lovely if you want to, separate the visuals of that state in state tree from the naming of the asset. Well, it's not state, it's a task, right? So separate visuals of the task on the state tree page. So quite cool. We have also an enum for formatting. We could switch on that, see what the options are. Yeah, we can have rich text, text. So depending on how we want to present it, rich text, of course, has a few more options we could do, and text is more basic. So nothing really to talk about here, is just visuals. So let's delete it, and we actually won't be using this, but it's good to know it's there. Moving on, are there any new fun things here? Unfortunately, no, and there are no new functions in either state tree task or the event graph of the character. So wherever we are using the state tree components, it's just, I guess, not really updated. But there is one more node that we can use. We'll get to that in a moment. So what's next? Well, naturally, when we have a task, we want to go to another task, maybe make some transitions, maybe make some grouping and something. So let's maybe split our logic into two state trees. This is something that we could do in 5.4 already, and it's kind of updated and upgraded in this version. So let's make a new state tree. Let's call it maybe st second, and that st second will have one state called entry in, and in that state we'll pick a task that will be a stock task. So debug text task, if you don't know, I don't think I actually showed that before, but the way that debug text works is basically rendering a 3D text widget in the world, and it displays the text you input here. So let's just type second. Let's make it red so it's nice and visible. Let's do font scale 2 so it's really nicely visible. And what is offset? Offset is basically a relative position. And relative to what? Great question. It's relative to reference actor. But reference actor can be empty. So if there is no reference, then it's just a world position. And if we input the actor, it's a relative position to that actor. I think it's pretty simple and works quite lovely. So now to jump to that state tree, from that state tree, we need to change that state from state to linked asset. And that asset will be our st second. Let's see quickly if it works. So now the our character should have, yeah, nice and big text visible second. So we know that the second state tree has run. And one bug that you might see now is that on the top there are some tabs missing, and it's a visual bug in 5.5 I noticed. And it's not really breaking anything, but it's kind of annoying, I guess, to look at if maybe you want to switch to tabs and see maybe the debug window. It's, well, it shouldn't be there, right? The tabs should be visible. So I guess one thing to report. And let's go to new stuff that we can do with that links. So when we go to AI character, you could see that we have a new option called linked state tree overrides. And it's a very nice, cool function that is not, I can't immediately think of many use cases for that, but could be useful if you wanted to sort of override, modularly override your logic in the state tree. So how does it work? Well, we need to make another state tree. So a state tree that we will want to replace that st second. So let's make, well, maybe let's just duplicate second and call it third. And in that third, we'll have a new, well, a different text. It will be called third. And in that third, it's just gonna render. And how do we override? We just do this and pick our new state tree. And now we can see that it's sort of a map, right? It has a key, which is a tag, and has a value, which is a state tree. And it basically picks what asset to override based on that tag. And when we go to the state tree, we could also see that the states do have tags. So basically to override that state tree with a new state tree, we have to pick the same tag on that state. Let's maybe pick a generic tag. We could also do test generic tag. One is just some tags that are stock in the engine. I think it comes with state tree plugin, so you should also have those tags. If you don't, you can use whatever tags you want. So yeah, test generic tag 1, and the same tag we need to add here. Test generic tag 1. And now when we run our state tree, it should print 3, third rather. And why didn't it print third? Good question. Okay, I figured it out. Maybe you notice a little slight cut. Actually, I forgot to pin that actor. So if you pin the actor to the context actor, and now it works fine. So it's third, right? I don't know how I missed that, but yeah, when you duplicate the state tree, then the actor is not actually copied for some reason. So yeah, make sure to check your bindings. I guess a little quirk of that version. So what did we do? Basically, we have the tut general. That tut general has a linked asset. It links to some asset, and we override that asset with a new asset. So instead of pointing to second, it now this points to third because of that asset. So yeah, that's overrides. You could also do it like you could expand on that, I suppose, because if we read that overrides for linked state trees, will that work if that would be just a link? I suppose not, because link state tree is kind of explicit, so probably not, but I guess it's like another hour of experimentation, and yeah, this is the general workflow. You could, take this knowledge and do all sorts of texts. It's kind of a lot here, so let's not dwell on that for too long. Let's go next. So maybe one thing that is very interesting in this version is that we have that payload. So maybe let's go to that payload and see what we could do with that. The entry, let's make a little example right here. Let's just, clean this up to general. We'll have one state that will be entry, and that entry, well, maybe not entry, let's do first and let's do second, right? And that first, will be our entry. And let's add a task to entry, so we have something to enter, right? This will be our tooth entry with hello world, and from that tooth entry we will want to jump to the second state, but not using the state trees, because that's one thing that is broken in this version, unfortunately. You could, in I guess 5.3 or 5.2, I forgot when it broke, you could do request transition, right? And that transition, well, before you could just promote this to a variable, expose it, and pick a state from here. Okay, let's maybe make a quick example how it works, how it should work. Yeah, you have that state tree request transition. The priority, I don't think it matters too much. And that target state will show right here. What is it? Here, target state. And you could pick just a second, and when you run it, then it should work. But unfortunately, it does not. So this does nothing. And if we maybe make just a debug text task, let's just do a works. Let's make it red, and that red will be bound to actor, scale to. We'll notice that, well, it never prints. That's because that node is broken, and it's still broken. Nobody fixed it. So Epic, please, if you listen to me, that would be great, and fix that node, please. So for now, you can't really do that from within state tree. You could do, I mean, what you always can do, so just finish task and, trigger a transition, whatever. But we are talking about so external signal to go to the next state tree or trigger a specific transition from external sources. So if we want to go from first to second using that external signal, then we need to make something called a send event. And that event will look like this. So on transition, we just want to pick on event. On that event, we want to transition to second. And now that is something that is changed and is basically this thing here, enter condition. We have tag and payload struct. So now we can pick a tag. This is something we already done in previous version. So we just pick what tag will trigger the transition. Let's pick test state tree tag. And now we can pick a payload. The payload is a very interesting thing, and it's not immediately obvious how it works, but it works. We need to pick a struct. So let's make a new struct, blueprint structure. Let's call it as payloaderinho, for example, linio. And let's make a funny float and let's make a funny int. Or maybe let's go crazy and let's do a funny string. Why not? Let's go crazy, am I right? YOLO, you live only once, right? And string. And now maybe let's do some default values. This will be 1. Let's start from 1, and funny string will be just funny. So let's save it. And now in that payload, where are we? Here. Maybe let's close that because we won't be using it anymore. Let's pick that payload. So as payloaderinho, and we can see that this is out. So we will be able to use that, but in a sort of wonky way, but not too much. I mean, if you know what to do, then it's not really difficult. It took me a while to understand it because in the state tree you don't actually have an access to that payload. You can't just type payload and expect it to work. You of course have access to that struct class, right? But you don't have the instance of that struct. So yeah, now we have a payload, and very important thing. Now the second will require event to enter, and then we need the same tag. So test state tree tag and payload struct pick the same that you picked before. So this as payloaderinho, and now this, whatever we pass in that event will be passed to that state. And whatever we have here, we can use in our tasks. Let's make another state tree task. We could also do it from here, of course. Let's call it STT payload test, maybe. Why not? Save. Enter state. And now we need a variable, and that variable will basically hold our payload. Also, payloads, if you watched my video about data management, well, it changes a few things, and there are more changes in the state tree that will sort of solve a lot of problems that I had in that data management. But let's focus on the video and let's keep going. Let's call it payload, and that payload will be of type as payloaderinho. And that payload will need to be instance editable, expose on spawn, actually just expose on spawn, but I like to pick both. And now when we compile, and pick a new task. Yeah, we want to replace with payload test. Now we have that payload, and that payload is basically whatever we have here. So funny float and funny string, and we can just bind to those, right? So enter event payload funny float, enter event payload funny string. And this is, boys, how do we use payloads? I mean, from the state tree. It also has a part too, but in a moment. And let's do a quick print so we know that those values are good. So I just break this. And let's maybe do a print text. Why not? Format, and let's do a quick debug print. So pay float and pay string, right? Like this, like this, like this. Great. And now to actually trigger that event, we could do that from within the state tree, sort of, but the intended way to use it, I mean, intended is kind of a big word because, I mean, intended is whatever you think is right for your project. But let's do it from here. So let's do send event. send state3 event. It will automatically pick that component. And let's break this, or rather, let's make this. And now that we broke this or made this, we can see that we have a tag, we have a payload, and we have an origin. And that origin, it was previously useless. We couldn't do anything with that. But now we could actually make a new variable called origin, or whatever, you know, the naming, you don't have to listen to me, just speak whatever, right? And in that name, when we go to that second state, we can see that the enter event also has origin. So that origin, now with the addition of payloads, can be passed from one state to another, which is absolutely lovely, and it will allow for very cool things to be made. And it's kind of, you know, built-in origin, so just use it. And now let's pick a tag. The tag is, of course, a test state3 tag. This is the tag that we want to trigger a transition with. So it will, if we are on this state, it's a little reminder, then it will check if there is an on-event transition on that state, and it will see if there is a tag that matches our tag, and it will try to transition to that state. So this is easy because we can leave it as none. We could do AI character, for example, and the payload is a little bit more interesting because the payload, if you hover over that little pin, it says instance struct structure. And instance struct is something, well, cool, but maybe not so, what's the word? I lost the word. Easy to understand, maybe let's call it that. Because you can't pick the struct we just made. So if we have payloaderinho, right, make, we can't really plug this into the payload. And this is done in this way, so we could pass any struct that we want. And how do we pass any struct that we want? Well, we need to make instance struct. And that struct is basically you plug whatever struct you want, it makes an instance struct from that, and it passes to that. And this is kind of it, right? We could also do a little delay, so we know that it's, well, so it doesn't transition immediately, and we have time to look in the left right corner, left top corner, top left, I think it's called. And yeah, well, let's make it to 5 so we know it's actually changed. And funny, let's change it to not funny. Yeah, and let's see if that works. If that works, we should see that print. Hello world, delay, not funny 5. Lovely. So those are payloads for you. I think it's pretty simple and extremely useful. Like, this was one of the major things missing from the state trees, and now it's here, so enjoy. This is how you use them. You could probably find a few more applications. But yeah, that's the basics. So let's continue and let's do something very, very fun, which is also addition in 5.5. I mentioned that I made a video about data management, and now what I'm gonna show you right now is something quite in that topic. So you could notice that we have those parameters in state trees, and those parameters, let's maybe make let's make a float and let's rename it to pretty float. And that pretty float, let's make it 7, just because. Now that parameter, you can pass to basically any state in that state tree that you want. And if it's a linked state, then you can pass that parameter to the parameter of that link, right? And previously, you could also, of course, see that in state tree. It should show as a parameter. I don't know why it's not showing. It's sort of bugged sometimes, but yeah, there it is, pretty float. You can set this immediately in the component. And you couldn't really change it, right? This is something I've been asking for a bit. So a way to take these parameters and change them, right? So we wanted to, I don't know, take that pretty float. We can't, maybe parameter, no, there is just audio, right? And there is one addition in this version that allows for changing those parameters. So let's make an example for that. First will be, we have tooth entry, and then we have payload test. So instead of doing this, we'll make a new, well, maybe let's not make a new variable yet. I'm just gonna show you the node. The node I'm talking about is not get a reference to self, but get property reference. And it doesn't look super crazy, but it's actually a crazy node. And that node is basically allowing us to take any parameter that we want from that state tree, change it because we have a reference, and it will be saved in that state tree parameters. So we effectively can get it in the one state, change in the second, and read in the third, and it will basically have the state, persistent state, right? So it will take the value of that value which was changed by the second state. And how do you use this? Very, very simple. You just take this node, promote to variable. You have that property ref. Then you have to let's make a print as well. And the property ref needs to have a type. So you need to know what you are sort of referencing. We know this is a float, so let's just make it a float. Compile, and it's all good, right? This is our hello. Maybe instead of hello, let's just print the value. And this will be the payload test. So from payload test, let's just do a little quick loop. So finish task. Let's do a delay, which is 0.2. And since we are doing a loop, we want to disable the send state tree event. And yeah, this will loop back to tooth entry, and tooth entry will loop back to the payload test. Finish task. Lovely. And we will also want to get this. Maybe without the print, but we want to get that reference and change it. Of course, mark this and this so it's visible. Let's change it to float. Let's make sure this is marked here as well. Tooth entry, lovely. This is our hello world. Let's take this property. And on every iteration, we just want to do ++. Right? And then delay, finish. Then we go to here, we just read it, then finish. As simple as that. So from first, we want to remove that event. We want to change it to on state completed or succeeded, whatever, it will both pass, and transition to second. From second, we want to remove the required event. Payload test, we don't need that. And just transition to the first. I guess this will sort of yell at me that it's not passed, so let's just remove this. We don't need it anymore, whatever. And maybe remove this as well. Hope it will let me pass. Oh, property ref, of course. Parameters, property ref, and same here. What do you want? Second state, event, enter event. Event is marked as, also, yeah. Yeah, so now it compiled. We just have transition from second to first and from first to second. And let's see if that works. Yeah. We are looping in our states. And in the second state, we are incrementing. On the first, we are reading, or other way around. On first, we are incrementing. On the second, we are reading. And you could basically make a list of parameters or even structs, like why not? You just need to pick the type and use this as storage. And you can use this in the whole state tree. So I think it's pretty lovely. And this is the method that I would use instead of making a new class that I showed you in data management video. So, do we have something else still? Let's see. I talked about state description. Request transition still broken. Yes. Payloads, yes. Parameters, states, tags. And also we have considerations, which is a new invention of that version. And it's basically conditions plus plus, sort of, because, you know, we have those conditions, enter conditions, and we have selection utility. Before we had just enter conditions and it was a boolean. Now we have a selection utility, which is a float. So to make a new consideration, just, you know, get this drop down, pick a new class. Let's call it st. Well, C is already for conditions, so maybe I actually don't know. Consideration, maybe, and tooth tests. All right, and it just has the get description, which all nodes, all state tree nodes have, and get score, and that score is basically our bool. So if we have a few things to pick, then it will be selected by the score. So let's maybe make a new group. That group will be called consider, and that consider will be a group, of course. Well, maybe not really a group, a state, because we need a selection behavior, and that selection behavior will work by this. So try select children with highest utility, and that highest utility is basically this selection utility, right? And we can have multiple children in that state, and it will just run the utility on each state and see which one is higher. So basically a priority, right? And the highest priority win. And this is the score, right? So you could basically type whatever you want. You could promote this to variable, say it's a score. And that score could be that pretty float, right? So let's put this here, put this here. This should be here. And the first will have selection utility, new consideration. Is it new? No, st consideration to test, right? And same here. And I forgot to mark this as expose on spawn. And now it's here, right? So you can bind the pretty float. And we could, you know, plug in a different variable, because of course this will be the same. So it will just pick the first. But if you have two variables, you want to check different things, or you have many different considerations, you could, of course, have those merges, right? So you have AND, you have OR, you can force some with true. I don't think actually it's here. In transition, you can force something as true, but I suppose not here. But I mean, you know, you could just combine those considerations, use those in different combinations, and just, you know, this is the enter condition, but it uses float, and yeah, basically that. So yeah, that's it from those updates. It's a bit longer than previous videos, but a lot of happened here. So yeah, we had to talk about everything, and yeah, I hope you enjoyed. I hope you learned something, and see you next time. Drop a like, drop a sub, drop a comment, of course, and bye bye.